Okay, let's do problem 6. Here they say segment MN has a length of 5 root 5 units. Point M is located at 4, 13, and point N is located at 9, y. Find the possible y coordinates of point N. Okay, one thing that's interesting here is they say the y coordinates plural, so maybe there's multiple possibilities. We know this one's a light bulb, so maybe they're trying to be tricky on us. So let's draw a little diagram again. We're going to say M is here, and point N is over here. Now we could graph this a little bit more precisely on a 4-quadrant graph, but we don't really need to. It's going to kind of just be an illustration for us to kind of visualize. We know that the length of this segment is 5 root 5. And we know point M has coordinates 4, 13. We know N has coordinates 9, y. Okay, so now for this one, they're asking us about the distance, or they're asking us about the coordinate, but we know the distance. And so that's making me think that we should use distance formula, where distance equals the square root of x1 minus x2 squared plus y1 minus y2 squared. And if we take a look at that formula, we know all of the variables in that formula except for y2 right here. And so we can plug in everything besides that second y coordinate, y2. We can say 5 root 5 equals the square root of x1, which is going to be 4, and x2 being 9. So we can say 4 minus 9 squared plus y1, which we know is going to be 13, plus y. That variable we don't know, squared. Okay, so now let's take that. We had 5 root 5 equals square root 4 minus 9 squared plus 13 minus y squared. And let's see if we can solve for y. So how do we do that? Well, we have the square root, the big square root on the right side, and we've got to get rid of that if we can. So what can we do? We can square both sides of the equation. As long as we do the same thing to both sides, we're okay. We keep it equal. And so we're going to get, after we do that, 5 root 5 squared. We're kind of distributing the square, that 2 exponent, to the 5 and the root 5. 5 squared is going to be 25. Root 5 squared, that pops it out of the radical, so just 5 times 5. And then equals, squaring this side is going to pop all this stuff out of the radical, so we can get rid of that. 4 minus 9 squared is negative 5 squared plus 13 minus y squared. Okay, let's keep simplifying. So negative 5 squared gives us 25. I'm going to go over here. Well, let's do that left side first. 25 times 5 is 125. Negative 5 squared is 25. Positive 25 plus 13 minus y squared. Okay, let's keep going. We can subtract 25 from both sides to get 100 equals 13 minus y squared. One thing you might be thinking to do at this step is trying to take the square root. And we're about to do that in this next step, but we can't do that up here quite yet because when you take the square root of both sides to solve an equation, you want to have the thing that's being squared, in this case the 13 minus y, all by itself already. And so by this next step, we get to that point where 13 minus y squared is all by itself on the right side of the equation. Now we can take the square root of both sides. And this is a case where we need to be very careful to use plus or minus. Squaring this, the 13 minus y, the square root of 13 minus y, or sorry, taking the square root of 13 minus y squared, those two undo each other, so we just get 13 minus y over here. And when you take the square root of both sides, we have to say plus or minus the square root of 100. Square root of 100 is 10, so plus or minus 10. Okay, well now it's making more sense why they say y coordinates plural. Because we're going to get two answers here. So we have 13 minus y equals plus or minus 10. When you have a plus or minus like this, we're going to break it into two equations. 13 minus y equals positive 10, and 13 minus y equals negative 10. Solving that top equation, we'll add y to both sides and subtract 10 to get 3 equals y. On the bottom, we'll add y to both sides and then add 10 to both sides to get y equals 23. And those are our two answers.